Okay, this morning we're going to be talking about some chords and diameters of circles and some other things about chords. First thing is that if you have a diameter of a circle, it always will be the perpendicular bisector of any chord that it intersects. So basically that means no matter what the circle looks like, if you've got some chord over here, if you draw a diameter is always the perpendicular bisector. Remember, diameter is just a chord through the center of the circle, equal to twice the radius. By perpendicular bisector, I mean this is going to be a right angle, and then these two pieces of the chord are going to be equal. Also, since these two pieces of the chord are equal, these two little arc measures are also equal. So if this arc measure over here is 50 degrees, this arc measure over here is 50 degrees. And if this part of the chord was 4, this part of the chord would be 4. So that's basically what you have going on for this first section. All three of those things go together. It's a right angle. It's splits the chord in half, and then it also splits the arc in half. Now, for this to be true, once again, this has to be a diameter of the circle, and it only works if it is a diameter. So that kind of works in both directions. If it's a diameter, you know it's true, and if it's true, you know that line is a diameter. The next thing we have is this information about equal chords. If two chords are equal, then the arcs that subtend the chord are equal. Basically, what this means is if I have a circle here, if this chord is equal to this chord, well, let's actually draw them so they are equal. That's always good. If these two chords are pretty much equal, then these arcs are equal. So this arc measure is equal to this arc measure. So once again, if this was 60 degrees here, this would be 60 degrees because the chords are equal. So if this was, 8, this would be 8. It's also true that the chords are the same distance from the center of the circle. Now remember, when you measure distance, you always have to measure at a right angle. It's kind of like if you were trying to figure out how tall you were, you'd have to put the yardstick or whatever you're measuring with perpendicular to the floor. Otherwise, if it was at an angle, you could make something really tall if you were measuring at an angle. So to measure, you always have to make a right angle. So these distances to the center are the same. So if that was 3 away, this was 3 away. And once again, all of those go together. The arcs being equal, the chords being equal, and the distance to the center being equal. At work,